When we have more than one relationship, all those relationships are similar to each other, then we are going to call that collection of relationship as a relationship set. When more than one entity, so if you consider the student as an entity, so this number of students will be more, but the teacher will be only one. So if I consider any of the entity, that entity will not going to have its primary key. So if I don't have a primary key, then I can't recognize it in a unique manner. Hello everybody, a warm welcome to one and all. Welcome back to the session 5 of chapter 2 of unit 1, B.C.A semester 4, subject called Database Management System, in short DBMS. I'm Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So we are in the last session of the chapter 2 of unit 1, that is what data modeling using entity relationship. So in our previous session, we had discussed regarding what you mean by an entity. As we all know that entity can be anything. It can be any real world object. We are going to represent an entity in the rectangular box. And also we have discussed regarding the type of an entity. That means what do you mean by entity type, and also I have discussed regarding the entity sets. Then attributes. So when it comes to the attributes, it is a property. So it is a behavior of an entity. That is what an attribute. And also we have learned regarding the types of attribute, whether it is what a single value attribute or a simple attribute, whether it is a composite attribute, and also we have learned regarding single valued attribute and then multi-valued attribute. And also I have discussed regarding the keys. So in order to identify the uniqueness in the table, then we are going to use this keys. There I have discussed regarding the primary key and also super key, then candidate key. So this is what I have discussed in my previous session. So in our today's session, we have more content to complete. So in our today's session, we will get to know regarding relationship types. So, and also I will be discussing regarding what you mean by relationship set. Then also we'll see what is roles and structural constraints, or what are the rules we have to follow. Along with that, under that structural constraint, we have a cardinality ratio. That is very important and very easy. Then we'll see about this participation constraint and existing dependencies. And so also we'll get to know regarding the weak entity. Then we'll see the most important and easy concept, that is ER diagram, entity relationship diagram, along with its symbol. Then I wanted to discuss regarding naming conventions and design aspects. If I wanted to give a name for an entity, attribute, or for a relationship, how must be the naming? So that is what I am discussing at my last content of today's session. So now we'll see about the first topic, that is with respect to relationship types. So before that, you have to understand what you mean by relationship first, right? So if you consider teacher and student, what is the relationship between those two? Student will going to learn from teacher, and teacher will going to teach us the student, isn't it? That is what the relationship, that is an association between two entities, will be considered as a relationship. So that relationship is an association between two entities, and also an attribute of one entity type refers to an entity of the same or different entity type. Then we can say that relationship exists in between the two entity type. When I can say when there is a relationship between one entity to another entity, so when an attribute of one entity will going to refers to attribute of another entity, then we can say that there is a relationship between this entity to another entity. So if you consider the student as an entity and marks as an entity, okay, so if I consider student, what student comprises of? Student ID will be there, and they are going to have a name, right? And also if I consider the marks as an entity, and also I have marks ID, and also I have a student ID. So here the student ID will going to, student ID is an attribute of this entity, and this marks will going to have a attribute called marks ID as well as the student ID. That means the student ID attribute of this entity will going to refers the attribute of another entity. Then we can say that there will be a relationship between the student as well as the marks entity, right? Then relationship is when one attribute of one entity type refers to another entity type. That is what you have to remember here. And also it represents the references as relationship, not as the attributes. So we are focusing on its relationship. We are not focusing on the attribute here. That is what you have to remember. And also how we are going to specify this relationship, that too with the help of diamond or a rhombus symbol. Student scores marks. So here, what is the relationship between student and marks entity? Student is one entity, marks is another entity. Then what is the relationship between those entities? That is what? Scores. Student will going to scores marks, right? That is the association between two entity. And also here you can see that next is what? Relationship set. So now we got to know regarding what you mean by relationship type. When there is an association from one entity to another entity, then we can say that as a relationship type. When it comes to the relationship set, it is a set of relationships of similar type is called relationship set. So when we have more than one relationship, all those relationships are similar to each other, then we are going to call that collection of relationship as a relationship set. Okay. And also, as per the entity, as we all know that every entity has its own attribute or its properties or a behavior. In the same way, this relationship is also going to have its own attributes. Then, instead of calling this as only attributes, we will call the attributes of the relationship as the descriptive attributes. Fine. So, we are going to have attributes for the relationship too, and whatever the attribute which is we have with respect to the relationship will be termed as descriptive attributes. So, here you can see that it is an what relationship set? I have a supplier and also I have a project here. So, these both will going to have a different relationship. So, this supplier will going to supply the content to the project, and also this project will going to get the supply from supplier. That is what these two are the different relationship, and if it is a similar type of relationship, then I can call that collection of relationship or a set of relationship as a relationship set. In the same way, this is also will going to have its own attributes, and that attributes will be considered as descriptive attributes. I hope you all understood regarding this relationship sets. So next we'll see about the roles and structural constraints. As the name indicates, roles. We have an entity, we have an attribute, and also we have relationship, right? So when it comes to the entity, there that represent any real world object, and also it specify its role. That means what is its work in the ER diagram, or what is its work in the representation of a database. The participation or the working of that entity will be considered as what? Role. Just imagine I am performing the role of teacher. So you are all performing the role of student. That is what? If I consider a student as an entity, teacher as an entity, everybody like all the entities will going to have its own attribute. Along with that, every attribute or every entity has got its own role. I am performing the role of teacher, I am performing the role of lecturer, and also you are performing the role of student. When you are at home, at that time you are going to perform the role of daughter or a son. That means each entity type that participates in a relationship type plays a particular role in the relationship. So that role will going to specify what is their work in the entity diagram or ER diagram. And also the role name signifies the role that participating the entity from the entity type which will place in each relationship instance, and it will going to helps to explain what the relationship means. That is what I told. Consider it is a teacher and also we have a student. So what is the role of a teacher here? They are teaching. What is the role of a student? They are learning, right? So student is a role and teacher is also a role. That is providing an association between these two entities. Then we are going to represent that with the help of relationship. That you have to remember here. So for example, if you consider the department as well as if you consider the employee. So if you consider the employee, employee will going to perform a role of employee, and department will going to perform the role of department as well as employer. That is what the relationship, right? So that is what a role here. Employee will going to perform a role of employee and department will going to perform a role of department or employer. And what is the relationship? Employee will going to works for department or for the employer. That is the relationship. Okay. So this is what you have to understand when it comes to the roles. And we'll see about the structural constraints here. So when it comes to the structural constraint, it is just a collaboration of this cardinality ratio and participation relationship. So together will be considered as what? Structural constraints. So this structural constraints is a collaboration of this cardinality ratio as well as the participation relationship. So if you consider the binary relationship, here also we have two main types, that is with respect to cardinality ratio as well as the participation. So when it comes to the binary relationship, at the time relationship types generally have a certain constraint. So why we are going to have a constraint? That means we are limiting its participation, or we are limiting the possible combination of the entities. So when it should not exceed at that time, for example, if you consider any events, at that time we are just going to make a constraint like only first 100 members can participate. That means what? We are just limiting the number of participation. We are limiting the combination of entities. That is what binary relationship here, that may participate in the corresponding relationship set. And also here, when there is a relationship where two entities are participating, will be considered as what? Binary relationship. When there is a relationship between two entities, that type of relationship will be considered as what? Binary relationship. We have two types in the binary relationship. One is cardinality ratio and another one is participation. We'll see about the cardinality ratio now. So first you have to understand what you mean by cardinality. Okay, so here cardinality is the number of instances of an entity from a relation that can be associated with another relation. For example, if you consider this as one relation, this as another relation, at that time how many number of instances of this relation will going to be associated with other relation? That means cardinality represents the number of instances of an entity. So if you consider this as an entity, this as another entity, how many instances of this entity is related to the instances of another entity will be considered as cardinality here. So there are four types of cardinality. First one is what? 1-to-1. So when one instances of an entity is related to the one instances of another entity, then we can say that that relationship is in the binary relationship with the cardinality ratio is 1-to-1. Then that means, let me consider one example here. Consider one first entity as a student. Okay, and consider another entity as a teacher. So student learns from, okay, so you just imagine we have one entity called student and also we have one more entity called teacher. So here this student entity instance will going to have a relationship with this teacher entity. So what is the relationship name here? That is learn from. Or else if I consider the example, teacher teaches student. So what it mean? So when we have a 1-to-1 relationship, at that time one teacher teaches one student at a time. That is what the cardinality ratio between these two entities. So when it comes to the 1-to-1 relationship, when only one instance of an entity is associated with a relationship, it is marked as 1:1. That is 1-to-1. So when only one instance of this entity is related to this entity will be considered as what? 1-to-1 relationship. In the same way, we have one-to-many. So one teacher will going to teach us many students at a time. So that will be the example for this 1-to-1 many. So here, when more than one instances of an entity is associated with a relationship, then it is marked as 1 to n. So when more than one entity, so if you consider the student as an entity, so this number of students will be more, but the teacher will be only one. Single teacher will going to teach us many students. Then that kind of cardinality ratio is considered as 1 to many. And if you consider the example of many to 1, so that is what I can consider. We have many students will going to learn from a single teacher, or else many students will going to opt single course, right? So at a time they can opt one course here. So many students will going to opt single course. So that is what many to 1. So when more than one instance of an entity is associated with a relationship, will be marked as many to 1. So here you have to remember n represent many and 1 represent 1 here. So next what we have, that is many to many. So when it comes to the many to many, at the time many teacher teaches many students. That is the example here. So many to many in the sense what? More than one instance of an entity on the left and more than one instances of the entity on the right can be associated with a relationship. So here also I have n number of instances and also there is a relationship with another entity in the terms of n number of instances. Then we can say that that is in the cardinality ratio of many to many. So that will going to describe many to many relationship. That is n is to n. Many teacher teaches many student. Is it at a time? No. So if you consider yourself, you will be teached or you will be lectured by many teachers till now. That is what many teachers teaches many students. So if you consider the first example here, 1 to 1, one teacher teaches one student, and also 1 to many, one teacher teaches many students, and also we have many to 1, many teachers will going to teach us single student, and also many teacher teaches many students. This is the cardinality ratio. So next what we have here, that is participation constraints and existent dependencies. When it comes to the participation constraint, that will going to specify whether the existence of an entity depends on its being related to another entity via relationship types. So here we are just finding out like participation in the sense what? An instance of this entity is related to the instance of another entity. We are just checking it. That is what participation is all about. For example, is this student belongs to this college or not? Or else is this student learned from this teacher or not? So here teacher is one entity and student is another entity. I am just checking whether this student learned from this teacher or not. That is what participation constraint, that will going to specify whether the existence of an entity which is depends on being related to another entity. Is the student is rely on this teacher for a particular type of subject? So that is what you can consider that as a relationship types. So that constraints are considered as participation constraint, and this will going to specify the minimum number of relationship instances that each entity can participate in, and it's sometimes called the minimum cardinality constraint. For example, if you consider the university, at that time if you wanted to opt any of the elective, then minimum 10 to 12 student must be there. So if the participation of 10 to 12 student is there for a particular subject, then only they will allow you to opt for a particular elective subject. That is what we are checking for the participation constraint. So that number of students are rely on particular subject. So if a participation is more, then the weightage will be high. So that is what you have to think regarding minimum cardinality constraint. And also when it comes to the participation constraint, it is of two types. One is total participation and another one is partial participation. When it comes to the total participation, each entity is involved in the relationship. So total participation is represented by double line. So for example, all the teacher will going to take a class for all the student. At that time, how can I say that? All the teachers entity. For example, you consider this is a teacher entity and this is what? Student entity. So at that time, all the teacher will going to teach all the students of a college. So this is one entity, this is another entity that you can see here. When it is a complete or a total participation, each entity which is involved in the relationship. So if you consider any entity, if it is completely participating in the relationship, then we are going to call that participation as a total participation, and it will be represented with a double line instead of single line. Okay. When it comes to the partial participation, at that time not all the entities are involved in the relationship. So for that reason, we are going to represent that with a single line. At that time, we had discussed regarding what many to many cardinality ratio. There I have only single line between the two entities. Association will be only single line. That means what? There is a situation of having this partial participation. Why? Because though I am taking a class for one to many, at that time there will be a situation that all the student will not going to attend. That means the participation is not complete in the relationship. So when we have a partial participation, that will going to be represented with the single line. I hope you all understood regarding this types of participation constraint. So next, we'll see about the weak entity. So now I got to know regarding an entity, right? So it can be anything, it can be any real world object. So that will going to be represented with the help of a rectangular symbol. Then what do you mean by weak entity here? So when weak entity in the DBMS which do not have a primary key and are dependent on the parent entity, then it mainly depends on another entity. So if I consider any of the entity, that entity will not going to have its primary key. So if I don't have a primary key, then I can't recognize it in a unique manner. So because with the help of a primary key, we are identifying it in the relationship or in the ER diagram in the DBMS. But when an entity does not have its own primary key and when it rely or when it depends on any of the parent entity, then we are going to call that kind of entity as a weak entity. So that entity type that do not have key attributes, that do not have key attributes of their own will be considered as weak entity types. Then what do you mean by regular entity types? So they have a key attribute. Then what do you mean by strong entity? So weak entity depend on the parent entity. When it comes to the strong entity, that do not depends on any other entity in the schema, then we are going to call that as a strong entity. So the strong entity will always going to have a primary key. If I have a primary key, then there will be no situation of rely or depends on any other parent entity. So that kind of entity will be considered as what? Strong entity. This is what regarding weak entity. So now we'll see about the ER diagram along with its symbol. So this is important with respect to your examination point of view. So till now we have learned so many data model and we got to know regarding what is entity, what is attribute, and it is what is relationship. Then can I going to write everything separately if I wanted to represent it in a diagrammatic format? There must be some association. There must be some relationship between one entity to another entity, and each entity should be described by its attributes. Then how we are going to represent it? That too with the help of this ER diagram, entity relationship diagram. So entity relationship model will going to be describes the structure of a database with the help of diagram. The diagrammatic representation of this entity relationship model will be considered as what? Entity relationship diagram, or in short ER diagram. And also this ER model is a design or a blueprint of a database that can later be implemented as a database. Now I am just writing its schema with the help of diagrammatic representation. Later I can implement that as a database, but as of now I am representing all the entities, attributes as well as its relationship with the help of this diagram. So that the main component of the ER models are entity set as well as relationship set. Already we know regarding entity set, and also we have learnt regarding this relationship set. So if I wanted to write any of the ER diagram, these two values or these two components will going to play a major role. And also in the ER diagrams, that it will going to emphasis on the representing of the schemas rather than the instances. So we are not bothering about the instance of particular entity. Instead of that, we are just focusing on its schema. So that will going to comprise of all the entity. Within the entity, we have a instance. We are not bothering about the instances when we are representing that in the ER diagram. So now we'll see about the shapes here. So these side are the symbol and this side will represent the meaning of that symbol. For example, if you wanted to represent any entity, then it has to be rectangular box, right? That represents the entity. And also we have a weak entity that will going to be represented by double rectangular box that represent the weak entity. Already we know regarding this diamond, that is rhombus, that represents the relationship. Then if I wanted to identify the relationship, then we are going to have this double diamond. And also we have this eclipse. So that is what? Attribute. So if I wanted to represent the key attribute, that attribute value will going to be underlined. If it is a multi-valued attribute, it will be like this. For example, if you wanted to take a phone number, so you are just representing what? Consider student. So student is an entity here. Entity will be represented with rectangular box and student will going to have a student ID and student will going to have a student name and student will going to have a phone number. So that is multi-valued. So I will represent that with a double ellipse. That is what you have to remember here. That is multi-valued attribute. And also we have composite attribute. For example, if I consider a student name. So if I consider a student name here, it will comprise of what? First name and also it has a middle name. In the same way it has last name, right? So this is how we are going to represent the composite attribute. When it comes to the derived attributes, so date of birth, age is the derived attribute. So from the date of birth, we are going to find the age. This is regarding derived attribute. And also we have participation here, total participation of E2 in relationship. So this E2 will going to have a complete participation in the relationship with E1. In the same way, this represent 1 to many. So cardinality ratio is 1 to many. And also if you consider this one, this is a structural constraint, minimum maximum on the participation. This represent minimum participation as well as the maximum participation. These are the symbols that we have in a ER diagram. With the help of this diagram symbol, you try to write a university database. What the university database consists of? It has a student, it has course, it has department, and each entity will going to have its own attribute, and which kind of attribute it is. Based on that, you try to write the university ER diagram and try to give the relationship between all the entities. So now we got to know regarding what all the symbol will going to represent. So now we'll see how we have to give the name for the entity, attribute or for the relationship. That is regarding what? Naming conventions and design aspects. So when it comes to the naming conventions, it is necessary to use singular names for entity types. I can't use teachers or I can't use departments. So instead of that, I just need to take only teacher as well as department. Okay, that is what you have to use singular name for the entity types rather than plural one. And also in the ER diagram, we have to use the convention that entity type and relation type names are uppercase letter. So it has to be in the uppercase. So if I consider a student, so instead of writing like this, I have to write in the uppercase. So that will be helpful in order to identify whether it is an entity type or a relationship types. That you have to remember. And attribute names are the initial letter capitalized. So when I'm writing an attribute, for example, if you consider the student as an entity, at that time, if it is name, so first letter must be capital in the attribute. So remaining values or characters can be small letter, but first initial letter needs to be capitalized. Then I can find that that is an attribute. And the role names are lowercase letter. For example, teacher, teachers. So that teachers will be the role, right? So if you consider the employee and employer, so they are performing their own role. So that has to be in the lowercase letter, right? So when it comes to the diagram naming, so at that time you have to use singular word, and also in the ER diagram, so it needs to be what? Entity type as well as the relationship should be in the uppercase, and attribute name first character must be in the uppercase as well as, and role names must be in the lowercase letter. Then when it comes to the design aspects, so I can't design everything in a single shot. Instead of that, it needs to be iterative. For example, if I wanted to add any of the entity, or if I wanted to delete the existing entity, at the time it must be dynamic. So that it means it must be iterative. It has to be loop. So that the schema design process should be considered as an iterative refinement process. Why it is iterative refinement process? In a single shot or at a particular time, we can't create or we can't develop complete ER diagram. First, you have to write a schema. So based on that, we are going to write the ER diagram. But that ER diagram is not yet finalized. So if I wanted to add any of the content, or if I wanted to remove the existing content, then it must be flexible. So we have to follow this iterative refinement process, where an initial design is created and then it are easily refined until the most suitable design is reached. So if I say, or if I'm okay with my ER diagram or a schema, then only I can stop this iterative refinement. Until that, we have to refine it more times in order to make a efficient and effective ER diagram which needs to represent any of the entity relationship data model. I hope you all understood. It's all about today's session as well as the end of a chapter, end of a unit. Let me meet you in the next session with a unit 2, that is with respect to the transaction. Until that, keep learning, keep on watching. Thank you.